The origin of seasons. Many people are unclear as to the origin of the seasons. Here are two graduates from Harvard University around 1986 who were asked to explain how the seasons occur. Here are their answers.
How hot it is or how cold it is at any given time of the year has to do with the closeness of the Earth to the Sun during the seasonal periods.
The Earth goes around the Sun, and it gets hotter when we get closer to the Sun, and it gets colder when we get further away from the Sun.
Like these students, many people hold a similar misconception, likely from a young age. Let's look at the distances of Earth from the Sun. The Earth's orbit around the Sun traces the path called an ellipse. The solid line is the elliptical orbit. If the orbit were a perfect circle, it would be this dashed line. By comparison, you can see that there's not much difference between the elliptical orbit and the circular orbit. Now consider, if this were true, that the seasons are based on Earth's distance from the Sun, shouldn't everyone on Earth experience winter at the same time when Earth is furthest from the Sun? And similarly, shouldn't we all have summer when Earth is closer? We know this isn't true, so there must be something else that causes summer and winter to occur at the same time in the northern and southern hemispheres. I'll return to this in a moment. Here's another picture showing the Earth's orbit around the Sun. Here are the closest and furthest distances to the Sun. 147,300,000 kilometers compared to 152,100,000 kilometers. In the northern hemisphere, we are closest to the Sun on January 3rd, winter time. While in the summer, July 4th, we in the northern hemisphere are actually further from the Sun. So this is another way of showing that the distance of the Earth from the Sun cannot account for the seasons. It's the tilt of the Earth to the Sun that is responsible for the seasons. The Earth's axis is tilted from the perpendicular to the Sun by 23.5 degrees. Notice there is less sunlight shining here than below the equator in the southern hemisphere. This shows that winter in the northern hemisphere occurs when Earth is tilted away from the Sun, and in summer the tilt of the Earth is toward the Sun, even though it is further from the Earth. So in the northern hemisphere, more sunlight is covering the northern hemisphere than in the southern hemisphere. Here is another way that explains the effect of tilt. Here are two rays of sunlight striking Earth. They both have the same amount of heat energy. This beam covers a smaller area, so this area feels more heat. The heat is concentrated over a smaller area. This beam is spread out over a larger area, so less heat is felt in this area. As a result, the northern hemisphere feels colder when Earth is tilted away, while the southern hemisphere feels warmer. Returning to this picture, let's consider spring and fall or autumn. Here's the Earth's tilt. Notice how it remains the same in every position. Now in spring and autumn, notice how the tilt is not pointing towards or away from the Sun. This makes the days and nights more equal in the spring and the autumn. In fact, there is one day in spring, March 20th or 21st, and one day in the autumn, September 22nd or 23rd, where the daylight hours are equal to the nighttime hours. Those are called the equinoxes. Equi means equal, and nox means night. So we have equal night, which implies also equal day. Here is Earth's position on June 21st or 22nd. This is known as the summer solstice, which is the beginning of summer. It is also the longest day of the year. 22 is in brackets because since 1800, only 8% of the summer solstices have been on this date. The 21st has been the solstice for about 74% of the time. Along this path, the days are getting shorter until the autumn equinox, when day and night are close to 12 hours each. The days continue getting shorter until December 21st or 22nd, the winter solstice, and the shortest day of the year. Since 1800, winter solstice has been on December 21st 63% of the time, and December 22nd 37% of the time. Winter starts here, but the days now start getting longer until the spring equinox, when day and night are once again equal. The days continue getting longer until June 21st, the summer solstice. And now a final comment. Although our year is divided into 4 seasons, the seasons are not all of equal length, and the reason for this is that the Earth doesn't orbit the Sun at the same speed. For example, on this side, where the distance between Earth and the Sun is shorter, in this area Earth is orbiting the Sun somewhat faster, whereas on this side, when Earth is further away, the Earth's speed is somewhat slower. As a result, we see here that fall lasts on average 89.8 days between September 22nd and December 21st. And then the winter season that follows averages 89.0 days. When spring starts, it lasts an average of 92.8 days, and then starting June 21st, summer lasts about 93.6 days. In the northern hemisphere, spring and summer together last about 7.5 days longer than fall and winter. That's nice for us. In the southern hemisphere, though, people in Australia, parts of South Africa, and most of South America, their summer and spring, on the right, which is our fall and winter, is about 7.5 days shorter. This ends the introduction to the seasons. Now, there are many misconceptions in this area. I have chosen 3 that I think are fairly common and hope to clarify. The first one is that the Sun is directly overhead at noon. Let's examine this diagram. The equator is the well-known imaginary line going around the circumference of Earth. The tropics of Cancer and Capricorn are imaginary lines that are 23.5 degrees north and south of the equator. Notice this is the same number as the tilt of the Earth. North of the Tropic of Cancer, the Sun will never be directly overhead, and south of the Tropic of Cancer, the Sun will also never be directly overhead. This will occur only between these 2 lines, known as the tropic zone. At the equator, the Sun will be directly overhead at noon twice, on March 20th and September 22nd. These are the spring and fall equinoxes. At the Tropic of Cancer, the Sun will be directly overhead on one day, June the 21st, which is the summer solstice. And at the Tropic of Capricorn, it will happen on one day, December 21st, the winter solstice. Within the tropic zone, the Sun will appear directly overhead twice on various days, depending on the particular location. The second misconception is that the days get longer in the summer and shorter in the winter. Let's look at this graph of hours of daylight on average for each month. Let's begin with the start of summer, June 21st, which is the longest day. As the summer progresses through June, July, and August, we see the number of daylight hours getting shorter. This continues until December 21st, which is the shortest day and the beginning of winter. As we continue through winter, notice that the number of daylight hours is increasing. So we see that although summer days are longer than winter days, they're actually getting shorter during the summer and longer during the winter. A third possible misconception is that winter and summer exist everywhere on Earth. The tropics between the Tropic of Cancer and Capricorn do not have the extremes of weather and summer temperatures found north and south of these latitudes. In the Western Hemisphere, we see the Tropic of Cancer passes through Mexico. The Tropic of Capricorn passes through Brazil near Sao Paulo. In between is the tropic zone. In this zone, there is a dry season and a rainy or wet season. The temperatures during the day rarely exceed 35 degrees, while nighttime generally remains above 22 degrees Celsius. At the equator, there are 2 dry seasons and 2 wet seasons during the year. And finally, I end with this question. Would Earth have seasons if it had no tilt? Here is the Earth showing its tilt, and here it is again. But let's now tilt the axis to the perpendicular position and consider the spin around this position. Would we still have seasons? What do you think? The answer is that there would just be one season forever. What kind of season would it be? Remember that at the spring and fall equinoxes, the tilt is not pointed toward or away from the sun, and that is when we get equal day and equal night, March 20th and September 23rd, which are the beginning of spring and fall. Our one season could be expected to be like it is on those days. And this ends the video about seasons.